Hello class, today what we're going to be doing is Boolean Algebra. So first thing we're going to do is go over a couple of things. We have the identity property, which means anything plus 0 is just going to be that anything. Same thing with 1 plus 0 equals 1, a plus 0 equals a. If you could do it with addition, you could do it with multiplication. Realize this isn't addition, this is the OR gate and this is the AND gate. So if you say anything and 1 equals that anything, you would be correct. You also have the inverse property, which is the same thing as in math class, except it's a little bit different. Instead of doing the reciprocal addition of fractions, you're doing a plus not a equals 1, because if a is 0, that means not a is 1. It means it's going to be 1 and vice versa. 1 plus 0 equals 1. The inverse property with multiplication, or the AND gate, just means it's always going to be 0 because you're going to have at least one 0. The constant property is basically the inverse of the identity property. If you add 1 to anything, it's always going to be 1. If you AND 0, you're always going to get 0. Commutative property also maintains. You can change the order. A plus a equals a, and a times a equals a, because 1 plus 1 equals 1, and 1 times 1 equals 1. Same as 0 times 0 equals 0, and 0 plus 0 equals 0. Distributive law, you guys all know this first one. A times the quantity b plus c is the same as, make it rain on them exponents, a times b plus a times c. However, what you don't know, what you need to pay attention to and you need to know on the test, you have a plus b times c. It's the same thing as above. You have a plus b and a plus c. A plus B and A plus C. This is different. This is the only thing that's different from standard math. Is this A plus B times C equals A plus B and A plus C. Realize all of these rules I'm going to give you, except for De Morgan's law. Which, De Morgan's theorem is this. A times B inverted equals not A or not B. Again, so if I have A times B, and I invert that, what happens is I'm inverting A, I'm inverting B, and I'm inverting the not. So what's the opposite of A? Not A. What's the opposite of and? Or. And what's the opposite of B? Not B. And that's how I get this right here. Please realize it could be something like this, where you have not A or B inverted. What's the opposite of not A? A. What's the opposite of or? And what's the opposite of B? Not B. And vice versa. This not could go over here, and then this would not be there, so on and so forth. This is just a pictorial representation. I don't know why they put the circles here. It's basically a triangle to invert, so ignore that. It's just a different way to write it, different syntax. I will not give you these two formulas. You're expected to know them, and you will be tested on them. Cough, cough. If you can apply it to 2 variables, you can apply it to 3 variables, but I won't be testing on this. Next one. This is the whole reason why we learn truth tables and why we learn K-maps. Is this sum of product form. Now, if we look at this sum of product form, we have this one right here. This one is not A, B, C. So we go over to the K-map. Not A, B, C is right here. We put a 1. This one right here is A not B, C, A not B, C, we put a 1 right there. This one right here is A, B not C, A, B not C is right here. And last but not least, A, B, C, A, B, C. This is how to go from a truth table to a K-map. And to get to a K-map to this, what we're doing here is, we are just making each and every single one of these individual circles. So this circle right here, ABC, is right there. AB not C, AB not C, A not BC, A not BC, and not ABC. So that's how we make 4 individual circles as a sum of product form. Now what we're going to do with this K-map is, this K-map is completely wrong. We don't want to have 4 individual circles. We want to group these together. So the first thing we ask ourselves is, can we draw a group of 8? No, we can't, because there's at least one 0. Can we draw a group of 4? No, we can't, because there's a 0 right here. Can we draw a group of 2? Yes. We can draw 1 group. We can draw 2 group. We can draw 3 group with a heartbreaker. What I want you to note right here is, how many times did we circle this one spot 3 times. Just remember in the back of your head this number just for this lesson. You can forget it in like 5 minutes. 3 times we used A, B, C. Let's try and simplify this. First thing we want to do is we want to see where does this have one change compared to the other ones. So what that means is not A turns into A, that's one change. B turns into not B, that's another change, which is 2 changes, so we can't use this one. Then we ask ourselves, does this go to this one? Well, not A goes to A, 1 change. B goes to B, 0 changes. And C goes to not C, 1 change. How many changes do we have? We have 2 changes, so we cannot combine these 2 sum products. So we're looking at not A, B, C. Does not A go to A? 1 change. Does B go to B? 0 changes. Does C go to C? 0 changes. So now what we're looking at is not A, B, C, and A, B, C. Why did I make the A red? The reason why I made the A red is it's different from the first term. What's the same between the 2 terms? We have BC, we have BC. We can factor out the BC. We are left with not A plus A. The reason why we can factor this out is this rule right here. The A is the BC. We factored out. Next thing we're going to be doing is this rule right here. A plus not A, what does it equal? 1. So, not A plus A equals 1. We bring down the BC. What's BC times 1? Equals BC. The reason why is the identity property of AND gates. A times 1 equals A. BC times 1 equals BC. So now we have this simplified down to BC. So what I'm going to do is I'm going to underline this and write BC. Now we go to the next term. I like to go left to right just because it's easier. You could go to this one. I already know these can't combine because I already checked that. But can A go to A? No change. Can not B go to B? 1 change. Can C go to not C? 1 change. 2 change. Can't do it. So we have to go to the next one. And can A go to A? Yes. Can not B go to B? 1 change. Can C go to C? 0 changes. So that means we can do it because there's only 1 change. So we're going to underline this with blue and underline this with blue. What can we factor out? We can factor out the AC because that's the thing that stays the same, and B is what changes. So inside the parentheses we have not B plus B. Order doesn't matter there. Not B plus B equals 1. AC times 1 equals AC. So we're left with BC plus AC. And we underline and we underline. And then we go to the last term, AB not C. AB not C, I already see that I have AB C. The C is the 1 change. So I can factor that out and just write AB. I don't have to write the, in parentheses, not C plus C, because I know it equals 1, I know that cancels out. Why do I have 3 lines underneath the ABC term? If we go back to the K-map, we have 3 circles on this ABC term. We use this ABC spot 3 times to simplify the K-map. Just like in our problem, we're using ABC 3 times. The mathematical equivalent of this would be, if I said 1 plus 2 plus 3 plus 4, green would be 1 plus 4, which would be 5. Blue would be 2 plus 4, which would be 6, and red would be 3 plus 4, which would be 7. That means this equals 18. That means 1 plus 2 plus 3 plus 4 equals 18, if we were to do that in math. So just realize this is completely different from what you were doing before. Now, the other thing to make my life easy, sort these alphabetically. So you have AB comes before AC, which comes before BC, and that would be the correct answer. That would be wrong. Technically, this would be right, but on Google Forms, this is the only one acceptable because I said so. The reason why we have to do that is otherwise I have to put in 3 times 2, 6 different options for a 3 output thing, and I'm just too lazy to do that. Solve this one. Feel free to screenshot and do this digitally if you want to. First thing you want to realize is I have A, I have A. I have not B, and I have B. Notice how I put the X's underneath and the lines to signify that they're the same. X's mean they cancel out. I'm just left with A. Can I combine BC with anything? No, because none of these have C. I'd have to remove C and add A, which is 2 X's. I can't do that. So the answer is just A plus BC. Now you're probably wondering why this is. We have a 3-variable K map. We'll say this is red. A, not B. A, not B. Both of these would be 1. It's a circle of 2. AB is both of these. And BC, B is in the middle, C is right here. So C is right here. Notice I drew 2 1s there. That's just because I circled it twice. Now we draw the K map. We get a circle of 2 and what? A circle of 4 to the floor. This is my circle of 4. This is my circle of 2. Done. Simplified. What this means is if you hate Boolean Algebra, make a K-map, draw circles, get the formula, and you get the same exact answer. Let's do another one. And another one. What you should have seen that you have X here, Y here, Y here. I crossed out the X's because they cancel out because we factor out the X. We're left with Y plus Y naught. But Y plus Y naught is 1. 1 times X is just X. And of course, we don't need to write that because we can just simply skip right to X. So good job if you got that right. If you didn't, that's fine. Here's another one. There's 2 of them actually, so get to these 2. Do the top one first. So the first one, you have this, which needs to match up with this one to get my 1 change, where only A changes. So I factor out the not B, not C. The not A plus A cancels out. So what I like to do is I like to underline both the terms that I use, the A and not A. And then I move on to the next one. Okay, you should have seen the one to combine this one is the last one, which is the first one you should have checked because the only thing that changes is the C. So I'm going to put an X underneath the C. And then I see that I'm left with A, B. And that's the answer because I can't combine these 2. To see the K-map, so the blue circle would be not B, not C, which would be right here. And the red circle would be these 2. You could make this circle. Does that circle help you simplify? No, it doesn't. You know the worst part is? You don't know which one you're circling when you're doing the math. So you could end up doing this circle, but it doesn't help you simplify, so you have to go back and try another combination. And the only way to figure that out is brute force. What I mean by brute force is, here to brute force this, you check this with every single one. Then you check this with every single one. Then you check this with every single one. And then you check this with every single one. And you see if you can simplify that. Which is a lot of work. Or you just hope you get lucky. Let's do the next one. Which realize there's a new one on the bottom now. The bottom became the top. So again, we're working on this problem right here is the same as this problem right here. We have A, B, not C, which the first one is this one. I factor out the A, B. Next one I look at is not A, not B, C. Matches up right here. Not A, B, C. So this is plus not A, C. Last but not least is this one right here. The question is, which one do I combine this with? I'm going to do this one right here because it's adjacent. And I factor out AC. Now I see that I have this term and this term. The A's change. I'm left with AB plus C. I'm going to ignore that purple box and just work on this one. What if I solve this a different way? So I'm going to match this one up with a different one, not this one. So I have AB, not C. I have to match it up with this one. That's the only option. So there's 2 changes here, not A, not B. There's 2 changes here with A and C. And there's 2 changes here with B and C. So my only option is this one, so I have to have AB, which that's half the reason why AB is in the answer. The next one, this green one, I'm going to match up with a different one, which I'm going to do this one. So I have not BC, so plus not BC. And this last one I'm going to match up with this one right here. Notice if I pick this one, it would work out. But I'm not going to pick that one because I want to show you why it doesn't work out. So this is going to be left with not A, C. Can I simplify that? No, I can't, because everything has two changes. Now, why is this? And what can I do to fix it? So let's look at the K-map. I'm going to draw these circles down here. In red, AB. I have not BC. Not BC, which would be these two. And I have not AC. Not AC, which is these two. Did I encompass the whole thing? Yes, I did. Did I make the group of 4 though? No. Realize this blue one, if this was just down one, I would have had a group of 4 and something would have canceled out. But because I did this, it didn't cancel out. To fix this, all I have to do is go up here and make another term. I'm going to combine something up here. I'm just going to say, let's combine this one again with this one. So I have not A changes to A. So I have BC. Now I have not B, not C. I can cancel that out and I'm left with C plus AB plus my blue is not AC. When I look at blue, is blue still covered by green and purple? Yes, it is. So I can completely remove blue because I underlined it and I see that it's already covered by other terms. So what that means in the K-map is I drew this circle, I combined it with green, so I got this circle, and then I removed the blue circle, which I'm not going to be able to get. Yeah, I did. And got that. Where the small purple and green are now the big purple. Realize to get this correct with this solution, I drew the red circle AB, the green circle not AC, and the blue circle AC. And then I combined blue and green to get purple. What that means is there's two different ways to solve this. I did top and bottom over here, I did middle and ends over here. Still get the same results. If you don't understand the K-map thing, don't worry about it. That's just to connect what we previously learned with what we're learning. Then we have duality. What duality is change pluses to times, change zeros to ones, and vice versa. What that means is if I can give you a rule with addition, there exists a rule with multiplication. That means if I give you 1, you should be able to produce 2. If I give you 2, you should be able to produce 1. And I'm giving you enough where you can't memorize them. That's the point. I want you to memorize this rule, not all of the rules. Because this is not all of the rules. There are lots and lots of them. So go ahead and try this one. When you're done with this one, there's 2 more problems on the bottom that I want you to work on. Okay, what you should have gotten was not ABC combines with ABC to give me BC. A not B not C combines with this one, which is A B not. And the last one, AB not C, combines with ABC to give me AB. B's cancel out. I'm left with A plus BC. To do this on the truth table, we have, let me give this a purple, not ABC, not ABC. We have A not B not C. We have A, B not C. We have A, B not C. And then we have the last one, which is black. ABC, which is ABC. Now, watch this real quick. You could have solved it this way to get this. Or you could have solved it this way to get this. Or you could have solved it this way and not able to simplify anything. Does everyone see that? And then you would think it'd be something looking like this, which it's not. So what that means is if you can't simplify after this step, you should go back up to this step and make different combinations to get something that looks like this and this. Your other option that would work would be this and this. Do you see how those both make a box of 4? This red one, BC, ooh, I don't want to do that. This purple one, with this term right here, has to be that circle. There's no other circle that'll work for that. Hopefully you can do this one, where you see A and you factor out the A, B plus C. The question is, can you do this one? So you should have seen that you have x plus, so you factored out x plus. You're left with YZ. Is this correct? Who thinks this is correct? I think it's correct. No one else got that? The only other tricky thing about this is Google Forms, you can't put this parenthesis in. So it had to be x plus yz. That's my only complaint. This would be correct. Because we are simplifying, so it should be simplified. But realize this distribution doesn't look right to most of you. It shouldn't look right, but it is right. Because this is not addition, this is or, this is not multiplication, it's and. So over here you would need parentheses. Over here you don't. Because there's no order there. What's up? What this is showing you is the similarities between Boolean algebra and truth tables. So we know these are the truth tables for and or not. But realize all these algebra theorems, like x plus x equals x, is because the truth tables are the same. For every single value that I put in for x, I'm going to get the same value as x. Also realize the double inverse is the same as x. We can get even to more complex theorems, which is might be something that you guys have to do, is I give you a theorem, you have to prove the theorem via a truth table. The only thing I'm going to give you is this. And you have to make the truth table out of that. You don't need to know the theorems to do this, because you should just be able to solve for the theorem. And again, you have even more theorems. But realize that these theorems right here, you can't visually see them and know that they're a theorem. But I will give you all these theorems so you can look at them. Even more, even more. And this is De Morgan's theorem proven, which again, I will not give you these two. And even more theorems, the consensus theorem. And this again is the notes on principal duality, not by mine. So if you don't like my way of explaining it, here's a different way to explain it. If you go to box.com, truth tables, De Morgan's, and logic circuits, it will be in the Boolean Algebra folder soon, but right now it's 165. Click on that, do that. Good luck. Have a good one. I will see you later.